Audio Jungle. Audio Jungle. Audio Jungle.
And welcome back to Weekend Projects with your tech friend Akshay Chawla. Today's session is a bit different from previous sessions, as previously we did projects on breadboard. But doing projects on breadboard, as you all know, are temporary. But what if we want that same projects permanent? So the solution is PCB, printed circuit board. As you can see, this is an example of PCB. Here is copper traces and here are the components. How is PCB different from breadboard? As you can see, this is breadboard, this is PCB. It is very huge, it is very tiny. The definition of PCB itself says that it is transformation of hookup wires into traces of copper. As you can see, there are a lot more difference, but the primary and foremost difference is that it is temporary and this is permanent. You can use it again and again. But it doesn't mean that breadboard is useless. Breadboard has its own use at its place. Whenever you do experiment, you want to change something, resistance value, capacitance value, you can change it in breadboard. You can't change anything in this. So today we will learn how to make PCB. Today's project will be how to make PCB, but we will learn it by making this project to vary brightness of LED by using LDR. If I will bring my hand in front of this, the brightness of LED will vary. You will learn today how to make this. For making a PCB, there are many steps. Steps like, for the first and foremost step is that you need a software to design PCB. How to design PCB? There are many softwares available online. You can choose Eagle, many other are there, but most user friendly is Express PCB software. It is a free software. You can download it from the link given below. And after that, after you design your circuit, you need to print it on glossy paper. Glossy paper is photo paper. You can print it on photo paper, then you have to cut it and get a PCB. PCB we use is glass epoxy PCB. It is special purpose PCB. We will use that, we will cut it and we will take the printout what we got and iron it. After ironing, we will put it in etching. After etching, what is etching? We will explain it to you later. What is etching? After etching, we will scrub it and then drill it. After drilling, we will just solder the components and we are done with our project. Now let's see what is Express PCB.
This is Express PCB. This is trace. You can click on it and get trace as you want. This is component manager. Here you can find all your components which you want, whichever you want. Right now we want 1-inch connector. Yes. And then this square one is positive, circle is negative. If you can see carefully, end of this which is grey, you can drag it. Now we need a resistor. We use 2.25 watt resistor. This is actually, resistor is used as LDR. We are making a voltage divider circuit. Now we need one more resistor, that is 10k resistor. All size of resistor is 0.25 inch. Now we will connect this with ground. Now we will connect a transistor. At voltage divider there will be transistor. Transistor is named as TO92. Base of transistor will be connected at voltage divider junction. Here we will connect ground. This we have to make 45 to increase the area. When we iron it, it might get cut off and we might not be able to notice that. So for that we make that cuts of 45. Now we need a resistor for LED. This will be 330 ohm resistor. Now we need a LED. LED we use 1.75 inch. Sorry. We will connect negative of LED to resistor and square one, which is positive, to power supply. This 2-pin connector is given for power supply. We will connect a battery here, 9 volt battery, or you can give 5 volt as you want. You can even name it by double clicking it. You can write LDR here. You can rotate the text orientation. You can move as you want. This transistor is BC547, which is NPN transistor. You can drag this too. Now when everything is done, you select it and copy paste it, because while printing, if there is any mistake in ironing, you can redo it. Now you can print your circuit, click on bottom layer and OK.
So hello, I have just cut the circuit diagram of the printout. See, this is printout. I have taken 4 printouts, as I told you that if after ironing circuit diagram is not clear, you can scrub it off. I have just cut it. After this you will require PCB. PCB, this is glass epoxy PCB. It is easily available on market. This is better one. I have now you have to cut this. I have already cut it off. Now you need to scrub it because it is bit rusted on the surface layer. You need to scrub it till it's shiny. Now after that you will need iron to iron it. Keep this printout on PCB and take iron and keep it on it in such a way that it doesn't move. It keeps steady on that PCB. It will take around 2 to 3 minutes to iron. Take care while removing this because currently it is very hot. Now as you can see, the path is transferred from this paper to this PCB. Now this PCB is ready to be etched. Now what is etching? Etching is basically a chemical reaction in which this PCB's copper reacts with FeCl3, which is our solution, to form copper chloride, and that settles down. And after that, the black path which is printed on this copper, on that path won't be removed because it is insulated by print. So we will get our desired path. But before etching, we need to drill a hole on this PCB. For that, let's come to drilling machine. I will let you know why are we drilling this. See, now the reason behind this is because when we etch, the solution is not friendly to our hands. It can cause itching and problem may occur in your skin. It may cause irritations. So for that, I have tied it with a hookup wire, and I will hang this so that I don't need to put my hand inside this. Now, solution's name is FeCl3, and it will take around 15 to 20 minutes for complete etching. After that you can take it out and wash it. I think it's done. Oh yes, it's done. Now we have to clean it. Avoid touching the solution. Now the next step is scrubbing. You need to scrub to remove the path of that print. We have to scrub until the path is shiny. You can see the copper shiny. Now our path is ready to get drilled. After that we will solder our components. The drill pin size is 0.6 mm. Now drilling is done. Next step is soldering. We need to solder the components. As we made a voltage divider circuit, and the components we require are resistors 10 kilo ohm and 330 ohm, LDR, transistor BC547, Rallymet connectors, LEDs, 9 volt battery and battery cap. I've got all the components over here: resistor, battery, Rallymets, everything. Now we will start soldering. For soldering you will require solder iron and solder wire. Solder wire is basically alloy of tin and lead. Why tin and lead? Because alloy of tin and lead has very low melting point, so it melts easily with solder iron. So we will start soldering. We will start with very small components and we will increase the size. We will start with resistors. For resistors, we have used 2 resistors, so we will check the value of resistor. So this is 10k resistor. It will be connected in voltage divider. As you can see, voltage dividers circuit. If you have confusion, you can open your PC by your side and then solder the components. I have created solder iron. Now how to solder? For soldering, hold solder iron in one hand, solder wire in other, and just touch the solder iron with where you want to solder and insert soldering wire from other side, and when you are done with it, just pull it off. After soldering, use this cutter. This is wire cutter, and cut this off. Cut the remaining part off. Similarly, we will solder all the other components. That's it. Now I am done with my soldering. After soldering, this is how it will look, and this is on the other side. I have connected 2 Rallymets. One is for power supply and one is for LED, because we will vary brightness of LED. Now we will connect battery and see what happens. Black is ground. We will connect black to black and red to red. connect it to our PCB. Now we will connect LED. Now see what happens as I bring my hand closer. The brightness of LED varies. See the brightness of LED is varying. This is our today's seminar. Now with this we end our today's session. Hope you liked it. If you have any queries, any problems, you can contact us on our email ID given below, or you can comment below for any queries. Thanks for watching.